This mathematical challenge to the theory of evolution concerns statistical barriers to the self-assembly of biomacromolecules, a computer simulation. This was presented by Marshall Jordan at the Dallas, Texas Creation Research Society meeting in July 2015. We begin with the evolutionist universe in a nutshell. Multiple steps are envisioned from the Big Bang all the way to macroscopic Darwinian evolution, which is microbe to man evolution. We're going to be concerned with the step macromolecular self-assembly. This process is thought to occur in a primordial soup containing organic molecules, including nucleic acids and amino acids, which spontaneously form polymers of DNA, RNA, or proteins. And then there's spontaneous generation of a macromolecule of specified complexity, that is, containing information. When I was in college, I didn't think about this as much as I should, and whenever a student would raise a mathematical objection to the theory of evolution or any of these processes, the professors had a standard answer. This standard answer seemed to satisfy me for many years, until I began to take the Bible seriously and what it was saying, and then I realized that from a mathematical standpoint, their answer was totally inadequate. The answer they gave was this: a monkey randomly pounding on a typewriter, given enough time, could eventually type the entire novel, Gone with the Wind, without error. Now, this same answer is still being given today, 30 or 40 years later, on the college campuses. It has been updated considerably. Here's the updated version. Notice that the monkey now has a laptop, and he's a little older. He's wearing glasses. His sleeves are rolled up. He's trying hard to type some large novel by randomly hitting the keyboard. This idea of a monkey with a typewriter has found its way into a variety of literature. Here are the savage chickens. Theoretically, 1,000,000 monkeys at 1,000,000 typewriters will eventually write Hamlet. And there's this monkey going clack, clack, clack. From an evolutionary standpoint, hasn't that already happened? I wrote a program, and here is the basic program. It simulates a monkey with a typewriter. It's a simplified typewriter with 26 keys, all caps. The monkey has to randomly hit the keys and type not the entire novel. That's too hard. Not even the first chapter or first sentence of the novel. He just has to hit the 15-letter string, Gone with the Wind, all caps, no spaces. The basic program is this: the monkey must get the entire 15-letter string on 15 consecutive keystrokes, or he must start all over again. Let's look at the probabilities. The chance of getting a G on the first keystroke on this simplified typewriter is 1 over 26. The chance of getting GO on 2 consecutive keystrokes is 1 over 26 squared. And the chance of getting GON on 3 consecutive keystrokes is 1 over 26 cubed, or 1 over 17,567. The chance of getting the entire 15-letter string, Gone with the Wind, is 1 over 26 to the 15th power, which is 0.596 times 10 to the 21st. That's one chance out of 1 over 596 quintillion. That is an incredibly small number. You should be very impressed with that, like this fellow. Here's the program. It generates a random number between 1 and 26 and then compares it to the matrix to see if it's an A, B, C, on through Z. If it's between 0 and 1, it's an A. If it's between 1 and less than or equal to 2, it's a B. All the way down to greater than 25 and less than or equal to 26, it's a Z. Now, if the first keystroke generates a G, the monkey gets to go on and try to get an O on the second keystroke. Otherwise, he has to start all over again. Here he is going for the second keystroke to try to get a GO. Can he do it? Well, let's see. I ran the program multiple times and found the probability of getting GON is, on the average, 0.000064 per trial. This compares favorably with the expected result of 1 over 26 cubed. A 1,000,000 trial run got 4 GONEs, although I expected only 2. An all-night run of 30 million trials produced 70 GONEs for a rate of 2.31 times 10 to the negative 6. I got 5 GONEWs for a rate of 6.15 times 10 to the negative 7th. I got no GONEWIs, but I expected to get one only once out of every 3 billion trials, so 30 million trials was nowhere close to this. The number of possible combinations of 15 letters is 1.68 times 10 to the 21st. When the number of trials exceeds half this number, that is 0.84 times 10 to the 21st, the probability of getting the 15-letter string becomes more likely than not. I use this as an estimate of success. At 100,000 trials per minute, this would take 8.4 times 10 to the 15th minutes, which is 16 billion years, longer than the alleged age of the universe. Running 100,000 trials per minute, this program is unlikely to randomly generate Gone with the Wind in 14.7 billion years. So if I can't get the 15-letter title, I can't get the 2 million letters of the whole novel. Therefore, it is impossible for a monkey randomly hitting the keys on a typewriter to type the novel Gone with the Wind in a universe of 14.7 billion years duration. Further discussion should include talking about information science, combinatorial space, and functional biomolecules. Let's consider hexokinase, for example. This molecule is involved with the first step of glycolysis, a common metabolic reaction found in bacteria and even the cells in your body. If abiogenesis and macromolecular self-assembly were to produce a functional biomolecule, wouldn't this be a good molecule to produce since it's so common to life on Earth? Let's consider it. Hexokinase has 460, 20 of the 20 proteogenic L-amino acids. And so the number of possible proteins you can make out of that many amino acids is 20 to the 460th. If amino acids in a primeval soup could randomly join to make a protein 460 units long, is it possible a functional hexokinase could be produced? The possibility of an unusual event occurring is determined by the probability of an event occurring at any one trial and the number of trials available. For example, if I have a bag of 10,000 white marbles with one red marble in it, and I randomly draw a marble, the chances of getting that marble on one trial is 1 over 10,000. But if I do 5,000 withdrawals, every withdrawal after that, it is more likely than not that I will get the red marble. So there's a theoretical limit to the number of events that can occur, or the number of times amino acids can interact with the possibility of forming a bond in the universe of finite age. A physical transition from one state to another cannot take place faster than light can traverse the smallest physically significant unit of distance, which is an indivisible quantum of space. That would be the Planck distance of 10 to the negative 33rd centimeters. Light at the speed of light takes 10 to the negative 43 seconds to traverse the Planck distance. The maximum interactions per second would then be 10 to the 43rd. A universe of 14.7 billion years is 10 to the 17th seconds, and the number of atoms in the universe is thought to be 10 to the 80th. So the maximum interactions since the alleged Big Bang is the number of atoms times the number of seconds times the number of interactions per second, or 10 to the 80th times 10 to the 17th times 10 to the 43rd, or 10 to the 140th. It is impossible for a biomacromolecule to self-assemble by randomly bonding of amino acid units because a 460-unit protein like hexokinase would not be likely to randomly assemble in less than 1/2 of 20 to the 460 trials. And a universe of 15 billion years duration allows only a maximum of 10 to the 140th trials. Since 20 to the 460th is far greater than 10 to the 140th, hexokinase can't randomly assemble. Now this underestimates the true magnitude of the problem. First off, L-amino acids only are found in living proteins, in living cells. So a racemic mixture or an inorganic production of amino acids in a primeval soup will have a mixture of half R forms and half L forms. Secondly, peptide bonds only must form to make a protein, a functional living protein. And amino acids can join by the side chain, Thirdly, you need proper conformation of the protein into its tertiary and quaternary structure. And you also need post-translational modification with moieties attached to the surface. But the major problem and the real black icing on the bitter cake of evolution is multiple copies. One copy of hexokinase does not a living cell make. You need hundreds, maybe thousands of copies of each protein involved with a living cell. So if a living cell has 100 different proteins, you need tens of thousands of copies of these, all in a small area of space surrounded by a membrane. This monkey has finally been laid off. He looks somewhat depressed to me, and his arm is sore from all the typing. It is impossible for a monkey randomly striking the keys on a typewriter to type "Gone with the Wind," and it's impossible for random assembly of amino acids in a primordial soup to produce a functional biomolecule. All the naturalistic explanations for the origin of life fail on the basis of these mathematical challenges. In fact, the only rational explanation for how life got here is that God created it. In the Bible, we read this. In Job 38, 4-7, God said to Job, "Were you there when I laid the foundations of the earth? Tell me if you have understanding." In John 1, 1-3, we read, "In the beginning was the Word, and the Word was with God, and the Word was God. He was in the beginning with God. All things were made through him, and without him nothing was made that was made." Revelation 4:11 says this, "You are worthy, O Lord, to receive glory and honor and power, for you created all things, and by your will they exist and were created." The only rational explanation for life on earth is that it was created by an intelligent being, namely God, and that's exactly what the Bible is telling us. Thank you for listening to this.